Hello, my name is Colin Henderson. Today I would like to share with you a summary of a project we undertook at Beekeeping Technology to compare the accuracy of colony strength assessed by infrared cameras with that determined by visual inspection. The work was done by my colleagues, Robert Seckham, Scott Debnam, and Jerry Bromenshenk, all of Beekeeping Technology. A bit about the project. We went into the field to collect infrared images from colonies, all done at night. We then compared those infrared images to visual inspections done first by commercial graders in the field and as a backup by visual inspection by the Beekeeping Technology researchers I mentioned before. We collected infrared images from sets of 500 colonies. Within 1 to 2 days of collecting those images, all of the colonies were inspected and graded. The inspections were done by commercial brokers for all 500 colonies. Additionally, the Beekeeping team did secondary visual inspections for 100 of those 500 colonies. In all, we recorded IR images from 1,500 colonies, 500 each in Southern, Central, and Northern California regions. In each region, we relied on local commercial graders to make visual inspections of the 500 colonies, but our Beekeeping team traveled to each of the 3 regions to secondarily inspect the 100 colonies in each of those regions. So in total, we had 1,500 colonies that were inspected commercially. 300 of those were then inspected by our Beekeeping team. A full report of our project findings was prepared and submitted to Project APIS-M. Copies of that report are available as PDF upon request at the email address listed below, bresearch@aol.com. Our overall goal for the project was this: to determine if a one-to-one equivalency between infrared images and visual inspection was possible. If so, IR imaging will be able to produce standardization of colony strength assessment. It will also lower labor costs for grading colonies to both growers, brokers, and beekeepers. The subsequent savings and reduction in time spent grading colonies should then allow every rented colony to be graded prior to deployment. Our first approach to the data, illustrated here in this chart, was to pair infrared determined frame counts with inspected frame counts and plot them against expected values. The blue line in the image shows what a one-to-one frame count would have produced in the correlation. As you can see from the chart, infrared images consistently overestimated frame counts below 10 frames per colony and consistently underestimated frame counts at frame counts above 10. In fact, the infrared generated frame counts were surprisingly consistent between roughly 3 and 19 frames per colony. Therefore, we could not establish a one-to-one equivalency of frame counts between IR and visual inspection. However, we did see a tendency for temperature profiles to vary with frame counts, and so we did additional analysis of the data. First, we grouped colonies by approximate colony strength relative or based on frame counts. We assumed strong colonies had greater than 10 frames of bees per colony. Moderately strong colonies were between 6 and 10 frames per colony, and weak colonies were those that had fewer than 6 frames per colony. Sorting them by strength and by region, we observed the following distribution. We had greater numbers of moderately strong colonies in Region 2. Region 3 had higher numbers of strong colonies, and so in an effort to balance the data in our 100 colonies that we assessed, we in Region 1 sampled more of the weak colonies for our follow-up analysis. I need to emphasize that our follow-up analysis was based on the 300 colonies that were inspected by Beekeeping Technology personnel. Okay. This is what we found. If you look at the picture on the left, in the graph, you see that there were distinct profiles for temperatures we assessed in colonies that were weak, strong, or moderate strength. We observed that weak colonies had the greatest number of colonies recording temperature profiles between 31 and approximately 39 degrees centigrade. Strong colonies had higher numbers appearing in temperature profiles from 39 to roughly 50 degrees temperature, and moderate colonies fell into a temperature profile between 51 and 59 degrees. We were a bit concerned that regional differences might be evident, and so we plotted the same temperature profiles by region for all colony strengths within region. As you can see, region 1 had temperature profiles that were more prevalent between 31 and 39 degrees. The moderate group that included, the high profile group in region 2 were between 39 and 50, and region 3 then mapped between 51 and 59. But those profiles were consistent with the higher numbers of colonies in each of the colony strengths illustrated on the left-hand side. So we felt that there was no distinct bias or difference in profile that was attributable just to region. What does that tell us? We conclude, because of that although a one-to-one correspondence between IR and visual frame counts was not possible, grading by relative strength is quick and reliable using infrared imagery. The only difficulty that we had with infrared imaging was our ability to segregate moderately weak from very weak colonies, that is, those that were in the group that were fewer than 6 frames per colony. Consequently, we are exploring development of infrared scan software for use across different camera brands to enable beekeepers and inspectors to grade colonies by thermal profile. So far, that software, which relies on pixel level interpretation of the image matrix, has produced results that are consistent with observer evaluations of the same thermal images. And so we have great hope and expectations that we will soon be able to have an algorithm usable with any camera brand that will enable rapid and effective colony grading. The resources from which most of our research was based includes several articles published by Jerry Bromenshenk on selection and use of IR cameras, as well as peer-reviewed articles from our colleagues at Montana State University, Joseph Shaw and his team, and the summary review that was prepared by our team, Bromenshenk et al., that was published just a few years ago. Thank you. We appreciate your attention.